The payoff matrix is the normal form representation of a static game of complete information, such as the prisoner's dilemma. The payoff matrix shows the payoffs for each of the 4 possible combinations of the strategies that Larry and Duncan may choose. The payoffs are negative because they represent years in jail, which is bad. In each cell, the first number is Larry's payoff, and the second number is Duncan's payoff. We use the best response approach, and we'll see that confess is the dominant strategy of both players. If Duncan chooses to confess, Larry gets 2 years in prison if he chooses to confess, but gets 5 years in jail if he decides to be silent. His best response is to confess. We underline his payoff -2. If Duncan chooses not to confess, Larry goes free if he talks and gets 1 year in prison if he remains silent. He is better off confessing. We underline the number 0. Confess is Larry's dominant strategy because it produces a higher payoff regardless of his rival's strategies. By the same type of reasoning, confess is also Duncan's dominant strategy. If Larry confesses, Duncan gets 2 years in prison if he chooses to confess, but gets 5 years in jail if he remains silent. We underline his payoff -2. If Larry does not confess, Duncan gets free if confessing, but 1 year in prison if not. His best response is confessing. We underline the payoff of 0. Duncan is also better off confessing no matter what his rival chooses. We then circle the cell with both payoffs underlined. It is the outcome of the Nash equilibrium of the game. Both players confess and get 2 years in jail. Let's try exercise 1.2.